Hello friends, my name is Ajay. Welcome to my channel. In part 1, we were discussed about what is power factor. The power factor is cosine of angle between voltage and current in a circuit. In this video, we are going to discuss about power factor in term of power and effect of low power factor in electrical engineering. Without wasting any time, let's start video. Industries use mostly inductive load and equipments like electric motors, alternators, transformer, relay, CT and PT, etc. Inductive load and equipments has properties like inductive reactance which oppose a change in current and internal resistance of material which oppose flow of current. In this circuit diagram, inductive load is connected to AC supply. L is inductance of the load and R is internal resistance of the load. A current flow in the circuit is I, which is lag behind the voltage by an angle phi. Current I has two components, I cos phi and I sin phi. I cos phi is a active component of current which is used by the load to perform useful work. It is in phase with voltage. I sin phi is a reactive component of current which is used by the load to produce magnetic field. It is lag behind the voltage by 90 degree. Current I is a vectorial sum of active and reactive component of current. In this current triangle, if we multiplied voltage, we get power triangle. In power triangle, Vi is a apparent power or demand power by the load. Vi cos phi is a active power or true power. Vi sin phi is a reactive power. Active power or true power is a power which consumed by the load to perform useful work. Reactive power is a power which does not consume by the load to perform useful work. It is flow back and forth from source to load and load to source. Apparent power is a power which demanded by load, which is vectorial sum of active and reactive power. It means load demanded both active and reactive power, but use only active power to perform useful work. For example, a packet of wafer. Packet is a apparent power, wafer is a active power, and nitrogen gas in the packet is reactive power. We eat only wafers. The nitrogen gas is useless for us. But in a packet, both wafer and nitrogen gas is present. Active power is given by Vi cos phi, where Vi is the apparent power and cos phi is a power factor. That's why active power is a product of apparent power and power factor. Therefore, we can say that power factor is a ratio of active power to apparent power. It means power factor is an indication of load that how much power is converted into useful work out of its demanding value of power. For example, if power factor of the motor is 0.5 and power demanded by motor is 1000 watt, then we get active power is equal to 500 watt. It means 500 watt out of 1000 watt is used for perform useful work. If power factor is low, then load demand more power but use less power to perform useful work. If power factor is unity, then load use all of demanded power for perform useful work. We know that industries use mostly inductive load. Therefore, the power factor is always low and lagging. Let's see what is the effect of low power factor. Required large kVA ratings of equipment. We know that power factor is ratio of active power to apparent power. So, if power factor is low, then apparent power is high. That is, we require large kVA rating of the equipment like alternator, transformer. Hence, its cost also increase. Greater size of the conductor required in transmission line. In transmission line current of the conductor is depend on power factor. If power factor is low, then line current increases. We know that current carrying capacity of conductor depends on cross-sectional area of conductor. So, greater size of conductor is required to carry high current. High copper loss. We know that for low power factor, large amount of line current is flow in a transmission line. Then I square R loss or copper loss is increased. Hence, it reduces transmission efficiency. Poor voltage regulation. Because of low power factor in transmission line, high line current flow, thus the voltage drop across line will increase. Then receiving end voltage is much smaller than sending end voltage. Hence, we get poor voltage regulation. To reduce this effect of low power factor, we should maintain power factor between 0.9 to 0.99. In next video, we will discuss about how to increase power factor or power factor correction. If you like my video, please share with your friends and subscribe my channel. Thanks for watching.